Hey, hi everyone. Today we are going to solve one of the interesting problem named as symmetric tree. And if you just recall our previous video, we have solved the same kind of problem. And what they are saying is we are given a root of a binary tree. We are given a root of binary tree, and we have to check if a left subtree of that particular tree and right subtree of that particular tree are mirror to itself. Can you see this image? In this image, this one is a root node, and there is a left subtree 2, 3, 4, and there is a right subtree 2, 4, 3. Both of them, like a left subtree and right subtree, are mirror to itself. Now, in this case, so this is a left subtree 2 and 3. There is a right subtree 2 and 3. And if you just take a mirror image of a 2 and 3, let me write this down for the example second. For the example 2, left subtree is 2 hyphen 3. This is like this. And mirror of a left subtree should be like this. The mirror image of a left subtree. And this left subtree and this right subtree is not equal. Okay. So we have to figure out if a left subtree of a particular tree and right subtree of a particular tree is mirror of each other or not. If it is a mirror, then just return true. So let's get to the pen and paper. So let's try with the examples. Suppose this is a left subtree, this is a right subtree, and both are mirror to each other. Suppose this is 2, 3, 4. The mirror image of this is 2, the 4 will come here, and this is 3. In this case, the answer is true. This is a symmetric tree. But in this case, mirror image of a 2, 3 will be 2 and 3 like this. So in this case, we will return false. So now let's start with the basics. So if root is null or if a root is null, then return true. That is a base case. If a root is not at all present, then return true. Now if now if root dot left and root dot right, the values of these two nodes, if that is not equal, if that is not equal, then return false. And if this is equal, then we have to follow the same procedure which we followed for the same tree problem. Okay. In this case, we will just call the same tree function. We'll just call the function is same tree, where we will take a left and right of a tree. And as I said earlier, if both are none, return true. Now, if both are not none, and values are equal, in this case, recur for left ka left and right node ka right, and same recur for left ka right and right ka left. That's all. Else, if any one of the node is none, then return false. So this is a pseudocode for this, and we will be visiting each node only once at a high level. So in this case, time complexity will be O of n and space complexity will be O of n if tree is skewed. Okay. So that's all. Let's try to code this problem. Let's try to code this problem. First of all, if a root is none, if root is none, then return true. If there is only one root and no left and right subtree, if root dot left is none and root dot right is none. In this case also return true because there is only one node and it is a mirror to itself. Return true. And if that is the not case, return call the function is symmetric. We have to write that function. It is not written it, so just keep calm. So root dot left and root dot right. We are passing the heads of a left subtree and right subtree to the function. Now we have to write the function left is symmetric or is a symmetric core. Let me rename like this to avoid the function name conflicts and take a root 1 and root 2. Root 1 comma root 2. If both the roots are none, then return true. If root 1 and is a none and root 2 is none, then return true. In the other case, if both are not none, if root 1 is not none and root 2 is not none, and if both are not none and values are same, root 1 dot value equal to root 2 dot value, then we have to recur for left subtree of a root 1 and right subtree of a root 2. So return call the same function. Let me copy the function name. I don't want to make any typos. So root 1 dot left comma root 2 dot right, and we have to recur for right subtree of a left right subtree of a left node and left subtree of a root 2 is symmetric core. This is root 1 dot right comma root 2 dot left, else return false. So that is how we should write the code. Let's try to run this. It is running fine. Let's try to submit this. Yeah, it is running fine. So the time complexity and space complexity for this code is time complexity will be O of n because we will visit n minus 1 nodes in the worst case apart from the root node, and space complexity for this function will be O of n because in the worst case that will be a height of a whole tree. I would say O of a height of a tree, which will be present into the implicit stack which is created by the recursion. So that's all about solving this problem using recursion.